So we need to calculate this problem, calculate the kinetic energy, potential energy, and the total energy of the electron in the ground state of a hydrogen atom. So the ground state, we have to use the formula. This is the ground state. Ground state level energy. Ground state means the electron is not yet agitated and moved to the other circuit. So normally the electrons are circulating the nucleus. So the electrons are normally within the atom. When the external energy put onto the electron get more energy and they passing through the forbidden gate and then they can move out. So this is called the ground state. The ground state means that the electron has not get the these are more energy. So in this case, we can write down the equation. Total energy equal to kinetic energy plus potential energy. So when the electron got the external energy, that energy will include the kinetic energy and the potential energy. So we use the equation to calculate. This equation is mv squared divided by r is equal to E squared divided by 4 by E0 and then R0, R squared. So this is called the equation to calculate the mass and the velocity of the atom. So in this case, we use like the kinetic energy. Ke is equal to the half mv squared, and the P equal to minus E squared divided by 4 by E0 into R1. So this is the equation to calculate the kinetic energy and the potential energy of the electron. So we can write down this equation, half into the mv squared is equal to, so this is a half into E squared divided by 4 by E0 R. So that one you can substitute here, half multiply, E will be the electron unit is 1 by 6 multiply 10 power minus 19 square divided by 4 multiply 3.14 multiply 8.854 into 10 power minus 12 multiply 0.529 multiply 10. So that by solving this one, you can got the 2.175 into 10 power minus 8, minus 18 joule. So that will be the kinetic energy of the electron. So we converted this one to 1 eV. 1 electron volt is equal to 1.6 into 10 power minus 19 joule. So this is for the 1 electron volt. So this energy we can convert it to electron volt. So the electron volt, this will be the 2.175 into 10 power minus 18 divided by 1.6 multiplied 10 power minus 19. So that will be 13.6 electron volt. So this is the energy of the electron. So calculate the kinetic energy, potential energy, we can utilize this equation and we can calculate the electron's energy. So that will be 13.6 electron volt. Another one with this problem, calculate. So those are, you can also see the notes from this book, but those are also combined with the other notes. So therefore, so this note page 1 to the page 10, only you need to refer. The next problem we can calculate the energy and rigidity of fast 4 orbits for an electron in a hydrogen atom. So first problem is we can calculate the electron energy. Electron energy is just for formula mv squared by r, so E divided by 4 by E0 R1, Ke is a half mv squared. And because of this one, we want the Ke, so we substitute the half, so we can calculate. And Pe is that we just use this equation. The next one is we also need to calculate the energy and the rigidity of the first 4 orbits for the electron in hydrogen atom. So this means the energy and rigidity. So energy we can use this formula. Electron energy is Ke is equal to kinetic energy is a half mv squared, and the potential energy Pe is equal to minus E squared divided by 4 by E0 R squared. So the total energy equal to Ke plus Pe. So that will be the half mv squared plus minus E squared divided by 4 by E0 R squared. So this is for the total energy and the Ke and Pe. And another thing is the electrons are radius. So to calculate the electron radius, we have to know the mass, velocity, and the radius is equal to nh by 2 pi. So that's the equation. So in this case, mass is the electrons are mass, P electrons are velocity, I is the electron radius, and this is the path. So this is electrons are circulating the nucleus, so the part number is the n. A is the Planck constant and the 2 pi. So this equation, we can find out the electrons are radius. And therefore, these equations are, we can find out the electron radius. So this equation we can get velocity is V is equal to nh divided by mr, so m pi. So this is the velocity V. So this equation, velocity V here, this for the electrons are, and we also you can use this equation. So half mv squared is equal to minus E squared divided by 4 by E0 R squared. So that this one we substitute half into m divided by nh by mr and by the whole square. This is equal to the minus E squared divided by 4 by E0 R squared. So that equation we can calculate for the electrons radius. Therefore, I is equal to E0 R squared divided by E0 A squared divided by 4 pi So this, we can solve this one, so you can, here you know the electron E, and here is the E0, and also the N. So this R is that if you want to determine, and H is the Planck constant, and then you can calculate the R. So this is the way we calculate for the energy and the radiity. Energy we can calculate by this equation. This is the energy, and this is the radiity we can calculate. So this one we saw it. That will be as NH divided by 2R. So N can cancel. This N cancel. So this is minus E squared divided by 4 by E0R squared. So IR cancel. So this is H by 2 pi equal to minus E squared divided by 4 by E0R. So then you can got the R. So 4 by E0R into H is equal to minus 2 pi E squared. So R can be calculated minus 2 pi E squared divided by 4 by E0H. So this is the radiation we can calculate. So electrons are radius, and also the kinetic energy can be calculated by this way. And the next problem is I explained it. First problem is that we have to calculate the kinetic energy and the potential energy, total energy. For the ground state means that the electron has not get the any energy to move out. So that time we can calculate. This is the ground state situation. So the formula is total energy is equal to the kinetic energy plus the potential energy. So this is the mv squared by r, and this is the e squared by 4 by E0R1. So K is a half mv squared, P is this formula. So half mv squared that we substitute, and then E is 1 by 6 and 10 power minus 19, the E0 value, and also R1 value you substitute, and then we can calculate the electron hole. Second formula is we can need to calculate the total energy and electron radiity. So total energy equation is this equation, and radiity equation that we use this formula, and we calculate the radiity equation. Second one is that when the electrons are energized, electron will be move out. Move out means that this is the state. This is the nucleus, and here with the electron. So this electron called the energy. So this one we jump to the another state. This is the another state we be going. This is the another state. So when the electron got the energy to the another state, what will happen is that it can emit the light. It can emit the light or it can emit the energy. Especially the photo cell. When the electric sunlight fall onto the photo cell, the electron in the one cell will be probably jump to the another cell. So in this case, by jumping, it can produce the electrical current or energy. And similarly, so this means that by emission of the any energy, electrons will be changing from the one state to another state. The change of the state is associated with the energy. So this means that change of the state is associated with energy emission. So the electrons are changed from the one state to another state, it will produce the energy. Similarly, when the energy is received by the electron, it will change to the one state to another state. So this is the relationship. So in this case, we can write down the equation. When the energies are changed, it can make the emission. So emission means that emission is an electromagnetic waveform. Light is also the form of the electromagnetic wave. So those electromagnetic waves can be written the formula. This formula is H multiplied F is equal to the W2 minus W1. So this is the equation. The H is you also know that H is equal to the Planck constant. F is the frequency, and And this one with the W2 minus W1 is the energy change. So in this case, we can calculate the W2 minus W1. How to calculate the W2 minus W1? That formula is M into V squared by R1 is equal to E squared divided by 4 by E0 R1 squared. So this equation. So this W is equal to the KE plus PE. So this equations we can calculate the potential energy and kinetic energy, and then by combination we got this energy state. So this energy state change from the one state to another state, it can produce a frequency. So this is the way we can calculate the hydrogen atom. So therefore we write down the equation is equal to the W is equal to minus E squared divided by 8 by E0 into R1. So in this case, MVR equal to the NH divided by 2 pi. And therefore we can write down the equation. V is equal to NH by 2 pi M into R. Then we set equation the half MV squared is equal to E squared divided by 8 pi E0 R1. So therefore, in the place of the V, you can substitute this 1 to the half M into NH by 2 pi MR squared divided by 8 pi E0 into R1. So therefore, by solving this equation, you can get that R1 is equal to the 529 into 10 power minus 19 meter squared. So that's equation. So normally we write down the energy state. WA is equal to minus E squared divided by 8 by E0 into 0.529 into 10 power minus 19. So that will be minus 13.6 divided by N squared electron volt. So this is the equation of the energy state. So electrons energy state, this W can be written as this equation. So minus 13.6 divided by N. So N value can be determined. The W1 equal to minus 13.6 divided by 1 square. W2 equal to minus 13.6 divided by 2 square. So W1 minus W2 we can calculate, and the frequency can be calculated. So the W1 and W2 you calculate. After this divided by the Planck constant, you can calculate the frequency. Therefore, we can calculate the frequency F is equal to W2 minus W1. So divided by H. So this is the F is equal to W2 is equal to the minus 13.6 divided by 2 square minus 13.6 divided by 1 square. And H is 8.854 into 10 power minus 34. So therefore you got the frequency. So this frequency is frequency emitted by the quantum. So this means when the energy state change from the one state to another state, the usually frequency will be produced. So this frequency is similar to the light emitting diode. Similarly, light emitting diode, when the electrical current flow through the LED, so you can see the light coming out. The reason is electrons from the one state to another state are jumping. One state to another state jumping, it produces a radiation. The radiation frequency is a light emission. So this is the basic principle of the light emission diode. Light emission diode means that electrical current flow through the atom, so electrons are jump from the one orbit to another orbit. So when the electron jump from the one orbit to another orbit, frequency is coming out. So this frequency can be the visible electromagnetic waveform. Electromagnetic waveform is depending on the wavelength. Some wake up visible. So this is the visible light coming out. So this problem is we need to calculate the frequency. Frequency equation is this is the ion driving. The main equation here. WA is the minus E squared by 8 by E0 into minus 13.6 by N squared. This is the major equation. So W1 is minus 13.6 by 1 square. W2 is minus 13.6 by 2 square. N means orbit 1, orbit 2. So W2 minus W1 The value divided by 8 by 8 by 4, so you call that frequency. This frequency is the visible range, so you can see the light. So this is the electron are changing from the one state to another state. It usually produces that frequency. So this frequency can be calculated. So the first problem is that we can calculate the electron energy at the ground state. Second problem is that we have to calculate the electron radius. Third problem is changing the one state to another state. Then we can calculate the frequency. Okay. Okay, so tonight we solve this problem.